Now let us discuss about quotient rule. The quotient rule is if you have a function which is represented by numerator divided by the denominator. That is, if, for example, y, which is f of x, is the top function divided by the bottom function. That is the numerator over the denominator, but most of the time for easily memorize the quotient rule, we use the one on the top divided by bottom. So T stand for the top, B stand for the bottom. Then and here and T derivative at x and B derivative at x exist, then we have the following. So the derivative of this one is b multiplied by b of x multiplied by t derivative at x minus here t of x b derivative at x divided by b of x the whole square. This is very important. Look at this is minus, unlike the product rule. Or simplified notation, or using simplified notation, we can write y prime, we can say b t prime minus t b prime over b square, or this can be written as also dy. The notation dy by dx is b dt by dx minus t db by dx over the whole b of x the whole square. So these are the same notation, right? So remember the quotient rule. Now let us use example to clarify this one. Example, let me say example 1. Let's say A, find f derivative at x for f of x is, let's say, x over x minus 16. Now you are asked to find the derivative of this one. So the first thing you need to identify is the top function is x, the bottom function is x minus 16, and the derivative of the top is just 1. The derivative of the bottom, this is the derivative, it is 1. Now look at this one. Says multiply this one with this one and this one with this one, but in between just use minus and square the bottom one. Therefore f derivative at x is just x minus 16 multiplied by 1. Remember, it is minus, and x multiplies 1. Commutative property also works if you just swipe the terms, is the same, divided by x minus 16 the whole square. Now let us simplify the bottom one. It is x minus 16 minus x over x minus 16 the whole square. If you look at this one, cancel this one, and the top one is minus 16 over x minus 16 the whole square. So this is the derivative of the given function. All right, the derivative, the simplified one, is negative 16 over x minus 16 the whole square. You don't need to expand the bottom one, so you can just leave as it is. Let me add another example. Find find f derivative at x for example, f of x is 9x minus 5 divided by 2x plus 3. So first I have to identify what is t of x. The top function is 9x minus 5 and the derivative is positive 9. The bottom function is 2x plus 3 and the derivative of the bottom function is just 2. And multiply this one by this and this one by this, but make sure that is minus and divided by the square of the bottom function. Therefore, the derivative of this one is given by 2x plus 3 multiplied by 9, or 9 times 2x plus 3 is also possible, minus 2 times 9x minus 5 over 2x plus 3 the whole square. You don't need to simplify the bottom one, but make sure to simplify the top. So this multiplied this one, it is 18x plus this times this one is 27 minus 18x plus 10 divided by 2x plus 3 the whole square. Make sure to multiply the negatives carefully, otherwise you make some mistakes. So when you look at this one, this cancel this one. So 27 plus 10 is, the top one is 37 over 2x plus 3 the whole square. That is the derivative of the function. So this is a derivative of the given function. Let's add more example. Let's say this is the third one, I think. Find f derivative at x for f is equal to, f of x is equal to, let's say, x squared plus 7 divided by 3x minus 8. Now, this one also you have to identify the top and the bottom. The top one is x squared plus 7 and the derivative of this one is 2x. The bottom function is 3x minus 8 and the derivative of this one is positive 3. Now multiply this one by this one, this one by this one, and minus and square the bottom one. So f derivative at x is 2x multiplies 3x minus 8 minus 3 multiplies x squared plus 7 and divided by 3x minus 8 the whole square. You don't need to simplify the bottom one, but make sure to simplify the top. So this multiplied by this one is 6x squared. And this multiplied by this one is minus 16x. This one is negative 3x squared. This multiplied by this one is minus 21 divided by 3x minus 8 the whole square. Now, like terms, this 6x squared minus 3x squared is 3x squared minus 16x minus 21 divided by 3x minus 8 the whole square. So this is the derivative of the function. All right, let's add one more. I have two more examples. Let's say example 4, find f derivative at x for f of x for x squared plus 3 divided by x squared plus 5, right? So when you see this one also, the first step that you need to do is identify the top function. The top function is 4x squared plus 3. and the derivative of this one is 8x. The bottom one is x squared plus 5, and the derivative of the bottom one is 2x. Then this multiplied this one, this multiplied this one, in between minus. Therefore, the derivative of the function is now 8x multiplied by x squared plus 5 minus 2x multiplies 4x squared plus 3 and divided by x squared plus 5 the whole square. Now make sure to simplify the top one, that is this multiplied by this one is 8x cubed. This multiplied by this one is plus 40x. This multiplied by this one is minus 8x cubed. And this one multiplied by this one is minus 6x, right? Divided by x squared plus 5 the whole square. Look at the top one. This is positive, this is negative, so cancel. And the only one remaining 14x minus 6x, they are the same terms, so it is 34x divided by x squared plus 5 the whole square. This is the derivative of the given function. All right, let me add one more example. This is number 5, I think. Find f derivative at x for f is equal to f of x is 7x minus 5 divided by x squared plus 3x. So the procedure is the same. First, identify the top function, 7x minus 5, and the derivative of this one is, it is just 7. The bottom one is x squared plus 3x, and the derivative of this one is, it is 2x plus 3. Now multiply this one minus and the square of the bottom one. Therefore, the derivative of this one is 7 multiplies x squared plus 3x minus the derivative of the bottom one is 2x plus 3, 7x minus 5 divided by x squared plus 3x the whole square. You don't need to simplify the bottom one, you just leave as it is. Now let us simplify the bottom one. 7 times x squared is 7x squared. 7 times 3x is 21x. Remember, this is minus, so this times this one is 14x squared, right? This one multiplied by this one is minus 10x. This one multiplied by this one is plus 21x. And this one multiplied by this one is minus 15. Remember the negative one. Don't forget this is negative. And this is divided by x squared plus 3x the whole square. So again, 7x squared plus 21x. The negative multiplies all the terms inside the parentheses. So this is negative 14x squared plus 10x minus 21x plus 15 divided by x squared plus 3x the whole square. When you look at this one like terms, so 7 and this one, you see, it is negative 7x squared. 21, this is positive, this is negative, cancel, and it is 0. Now, the remaining are plus 10x plus plus 15 divided by x squared plus 3x the whole square. So this is the final simplified form of the derivative of the given function.